Electricity is the invisible thread tying my day together. From the buzz of my toothbrush to the glow of city skylines. But what is it really? At its core, electricity is the flow of electrons. Voltage is the push. Current is the flow. Resistance shapes the ride. Push harder with more voltage and, if resistance stays the same, you get more current. Zoom in to the atom. Electrons orbiting nuclei loosely held in metals like copper. Give them a push, and they drift along a wire like a slow-moving crowd that still carries messages at near-light speed. Where does that push come from? Most often, spinning magnets past coils of wire. That's electromagnetic induction. Change a magnetic field, and you make a voltage. Turbines do the spinning. Steam from burning fuel or nuclear heat wind across blades, water falling through dams. All of it turns a rotor inside a generator. Even solar panels fit the story. They don't spin, sunlight knocks electrons loose in semiconductors, creating voltage directly. Now, the great current debate, AC versus DC. DC, direct current, flows one way, like from a battery. AC, alternating current, wiggles back and forth. AC won the early grid battle because transformers can easily step voltages up for long-distance transmission and down for safe home use with minimal loss. Today, high-voltage DC is making a comeback for very long lines and undersea cables because it can reduce some losses. But in your wall, it's almost always AC. Inside your home, power arrives as hot neutral plus a safety ground. Circuit breakers are the bodyguards. They trip when current exceeds a safe limit. GFCIs watch for tiny imbalances between hot and neutral. If current leaks, say through water and you, they cut power in milliseconds. Outlets, fuses, proper wire gauges, these aren't just rules, they're layers of protection. Switch scenes from rooms to chips. Electronics involve precision control of current. Resistors tame it, turning electrical energy into heat to set levels. Capacitors store charge and release it on cue, smoothing ripples or timing signals. Inductors resist changes in current, great for filters. And the transistor? It's the microscopic gatekeeper that lets a tiny signal control a larger current. Logic, memory, the smartphone in your pocket, billions of transistors switching on and off create these. Real-world touch points are everywhere. Flip an LED lamp. It sips power because it turns current into light with far less heat. Induction cooktops? They generate changing magnetic fields that make current flow right in your pan. Wireless charging uses coils and alternating magnetic fields to move energy across small gaps. Same principle, no wire. So what's next? Smart grids that route electricity like data, balancing rooftop solar batteries and demand in real time. Solid-state transformers that shrink substations to cabinet size. Vehicle-to-grid cars acting like rolling power banks. Materials breakthroughs. Superconductors at more practical temperatures could slash losses. Electricity is motion at the electron scale, shaping human-scale life. Turbines to transistors, it's one connected story. Energy, converted, guided, and used with care. Understand the push, the flow, and the rules, and the world starts to make a lot more sense. And maybe, the next time a light turns on, you'll see the hidden choreography that made it happen.